Yeah, hello, welcome back to another video. Today's video we'll be doing exercise 1E. Kind of just been doing all these on break. Um, Pretty fun stuff. Not really, but it's okay. All right, so exercise 1E asks us to prove that parenthesis a plus b parenthesis squared plus parenthesis a minus b squared is equal to 2. Actually, I'll just write this down. It's equal to 2a squared plus b squared. Okay, we're on to proofs now. The beginning stages of proofs are going to be definitely a bit more simpler than last time, but they're going to get hard. Let's go ahead and start this. When you're doing proofs, you can only do one hand at a time. Never try both. So we'll start with the left hand. So we have, I'm just going to factor this out even more. Now after factoring everything out, remember our rules. Plus b squared. And then combining like terms, we get 2a squared. These cancel out. Oh, that's a b squared. Plus b, 2b squared. And factoring the 2 out, you get 2 times a squared plus b squared. And that is it. Make sure you put the QED at the end to show that you're done. Let's go on to number 2. Okay. Show that a product of two odd numbers is always an odd number. Okay. An odd number is defined by 2n plus or minus 1, usually minus 1. That is asking us that the product of two odd numbers is always an odd number. So that means that one odd number multiplied by another odd number is going to be equal to an odd number. Uh, this is asking for two different odd numbers, so let me write it like that, because technically that's not true. We'll do that. These are all odd numbers though, that's all you need to know. But after multiplying these, you end up getting 2 and m. Oh, sorry. You end up getting 4 and m plus 2n plus 2m plus 1. And we can actually factor a 2 out from this entire thing. So then we'll get 2, 2nm plus 2n, oh, plus just n plus m plus 1. Let me put that up here. And then let's just let this entire thing here be equal to any integer of the sort. So let's just have L as our integer. So now that gives us 2L plus 1. And hey, would you look at that? It's an odd number. It's not what we got over here because once you square these became positive, but I can just make that positive and it's an odd number. So therefore, that is true, and that's QED right there. All you need to do. And that should be an L. And we do know that L is just any integer, so that's why this is true. Alright. Number 3. Prove that a 4-digit number is divisible by 9. Oh, prove that if a 4-digit number is divisible by 9. Okay, sorry. Prove that a 4-digit number that is divisible by 9. Oh my god. I do not have dyslexia. I don't know why I'm not able to read this. Prove that a 4-digit number is divisible by 9 if the sum of its digits if the sum of its digits are divisible by 9. Hence, identify which of the numbers. Let me write these numbers down. 3978, 98, 64, 5670, 5453, and 7898. Hence, determine if those numbers are divisible by 9. Okay, so basically what it's saying is just any 4-digit number that's divisible by 9 is divisible by 9 if its sums add up to 9, which is that is true. I remember seeing a couple of videos on that back a while ago. But let's just let any 4-digit number be represented by this: A3, A2, A1, and A0. These are all numbers. They're not products. They're not multiplying anything. Remember that. This means that A3, that's going to be our thousands place. So that's going to be times that. And that's going to be plus A2, which is in the hundreds place. So that's going to be times 10 to the second, plus A1 times 10, and plus our what? A0, which is multiplied by 10 to the 0, which is just 1. And we're told that the sum of these digits has to be equal to a divisible a divisibility by 9. So it has to be equal to like 9m, such that m is an element of the positive integers. Okay. Therefore, we can separate what we got over here like this. 10 cubed is equal to 1,000, so we can just make that like that, right? And we can do the same thing for A2 times 10 to the second, except that's going to become 99 plus 1 plus 9 plus 1 plus A to the 0. Okay. Now, we're actually able to factor out some of these numbers here. This is going to go into here, and like that. It's going to come into here, like that, here, like that. We're able to factor it out like that. So let's write it like that with the 9s in one parentheses and just the A3s and A2s in another parenthesis. And we're going to cut out the A0 because we don't have that there. And that's going to be plus by A cubed, well, A3, A2, A1, and A0. Okay, can agree on that. Now, remember what we were told here, what we said earlier. We said that this is equal to 9m. And by factoring out a 9 from all this, oh, that's not good. And by factoring out a 9 from all this, we can put a 9 out here. It's 99 A3 plus 9. Okay, whoops, huge mistake. That is not how you factor. Okay, 111 A3 plus 11 A2 plus A1 plus 9m. And we can actually also add the m into here and factor it all one more time. There we go. And that is our proof. That is QED. And the reason that's the proof is because look at that, we factored a 9. That means that it is in fact divisible by 9. Now that we have that, and we show that it is true, we come over here and we see which digits are able to get divided by 9. Let's try the first one. 3 plus 9 is 12, plus 15, you get 27. That's divisible by 9, so this entire term is divisible by 9. Check mark that. 9 plus 8 is 17, plus 10, 27, divisible by 9. We have 7 plus 11, 18, divisible by 9. Okay, 8 plus 9 is equal to 17. That is not divisible by 9. 8 plus 8, 16, plus 16 again, 32, not divisible by 9. Okay, so first three numbers are divisible by 9. All right, let's go on to number 4. Number 4 is asking us to show this whole conglomerate of an equation. A squared plus b squared times c squared plus d squared is in fact equal to AD plus BC squared plus, how did minus get in here? Okay, BD minus AC, it'll probably work out in the end, square. Okay, hopefully this is a easier proof. So I'm gonna start with the left hand side. We can create our little box right here to solve all this. A squared c squared plus b squared c squared plus a squared b squared. This is a lot of writing. Plus b squared d squared. I'm just going to keep that like that for now. That's a simple term. There's definitely a way where you can expand it out to make that, but that's a bit harder. So we'll go on to the easier way and just switch to the right hand side now. If you remember our rules, that's going to equal that plus 2. Uh, shoot. 2 ADBC plus b squared c squared. Then on this side, we'll have minus 2 ABCD plus a squared c squared. And don't forget the plus b squared d squared. Okay, this is pretty long, but a bunch of that cancels out. This cancels. Actually, that was the only thing that canceled. Now we have a squared d squared plus b squared c squared plus a squared c squared plus b squared d squared. Hey, would you look at that? That equals that. So that is Q E D. Okay, 5 is telling us to prove that 1 divided by 3 plus 1 divided by 9. So, oh, whoa. 2. Oh, shoot, I read that wrong. Minus 2 divided by 9 plus 1 divided by 27 minus 2 divided by 81, so on and so forth, is equal to 1 over 8, which is equal to the sum of all that. Okay, this is going to be a bit of a more difficult proof, but it's still doable. We're basically just going to have to factor a bunch of this out. We know that s is equal to 1 over 3 minus 2 over 9 can be just rewritten as 1 over 3 Wait, no, I'm skipping too far. We can actually simplify this. Sorry, not simplify it, but we can make this look a bit better by putting the positives on one side and the negatives on one side. So we have plus 1 over 27 plus 1 over 4th root of 3, which is 243, dot, dot, dot. And at the end, we're just going to return here. So we'll have 2 over 9 minus 2 over 81 minus 2 over 729 and so on. So from here now we can factor out a couple of things. 1 divided by 27 is just going to equal to 1 divided by 3 times 1 divided by 3 squared. And then, we continue on doing what we were just doing. What we're going to be doing here is just basically factoring every 1/3 out that we can on the positive side. Then on the negative side, we're going to factor this -2 out from all of this. So then we can just leave this with 9 since these are all multiples of 9s. We can end up just getting this. And what we end up getting here are two different infinite geometric series. And both of these series converge because we're told that right here they're going to end up equaling 1/8. And they both have a common ratio. So let's just end up splitting these apart. So we know that the common ratio for our first one is going to just be 1/3 squared divided by 1/3, which is equal to 1/3. Then our common ratio here is going to be 1/9 squared divided by 1/9, which is equal to 1/9. So then, using the formula in our book, we know that the sum of a infinite converging series is going to be u1 divided by 1 minus r. So our u1 in the first case is 1 divided by 3, and our r is oh, sorry, I messed up here. This is supposed to be cubed because this is the thing right here. And it's going to be 1 divided by 3 squared, which is 1 to the 9. Sorry about that. I forgot this thing over here is 1 divided by 27. So 1 divided by 3 cubed divided by 1 divided by 3 is 1/9. So that's our answer to the first one. Then our second one, remember we have a 2 here, so we have to consider that in there. U1 is equal to 9, and that's going to be subtracted 1/9, just like that. And now, doing some math, I'll actually show how this plays out. 1 divided by 3 times 9/8 is 2. 1 divided by 9 times 9/8. And that ends up all canceling out. That cancels out. So you can just make that into 3 times 3. And then that'll cancel out. That'll become 3. So then we're left with 3, 1/8 minus 2, 1/8. And that equals 1/8. So QED. Like I'm writing big over here. Okay. Number 6. We need to prove the difference between the square. Prove that the difference between the squares of two consecutive numbers is always an odd number. Okay. Saying the difference. Okay, this should be easy. So one of these square numbers are going to be 2 plus 1, and the other is just going to be, or n plus 1 squared, and the other one's just going to be n squared, and it's asking us to show that the difference is equal to an odd number. Okay, that's doable. So n plus 1 squared minus n squared, factoring all this out, we get n squared plus 2n plus 1 minus n squared. And hey, look at that. Mm, yeah, okay. Thought I messed out. Messed up somewhere. Oh, look at that. 2n plus 1 QED. That's an odd number. We know that from definitions. Come on, go down. Number 7, show that 1 divided by n minus 1 minus 1 divided by n plus 1 divided by n plus 1 is equal to n squared plus 1 divided by n parenthesis n squared. And oh, that's small. What is that? Okay. And then after that, it asks us to determine the value of 1/5 minus 1/6 plus 1/7. Okay, so first we need to actually prove that this is true. Simple way to do this is just make all the denominators the same. You can do this by multiplying n up here, n plus 1 up here. Same thing over here. Denominators end up matching. We know how it goes. So for our first one, we're going to have n plus 1. And since all the denominators are just going to end up being the same for all this, I'm just going to set it like this. And for our second one, we need an n minus 1 and a denominator plus an n plus 1. And then for our third one, we're going to need an n minus 1 and an n. And this is all over n minus 1, n plus 1. I think at the end we'll end up canceling everything. Okay. Looks like we can just simplify everything. It's probably the easiest way. So we end up getting n squared plus n minus, if you remember our rules, this is equal to n squared minus 1 squared. That's going to be n squared plus 1. Actually, for a certain sake, we'll keep it in parentheses like this, plus n squared minus n. Okay, so now this cancels out already, so now we're left with n squared minus n squared minus 1 is n squared over this. And then remember what we were saying earlier, how this is equal to that. Well, look what we have at the bottom. We have this, so we can end up canceling these terms. Those cancels out. Like I missed something. No, I did not miss anything. No, I definitely missed something. Oh, it doesn't want us to cancel that. Okay, well, we won't cancel it then. Sorry about that. They want us to keep the whole thing over there. Okay, so we won't cancel that. This is going to end up equaling, those cancels out. That's a negative, so that ends up equaling n squared plus 1, which is what we had earlier, n squared minus 1. QED. I got a bit ahead of myself. Okay, now that we know that's true, we can solve this problem. In this case, 6 is going to be our n. So now we have 6 squared plus 1 divided by 6. 6 squared minus 1. After doing some math, you'll end up getting 37 divided by 174. Okay, 8, we're on our last problem. I'll actually draw this one this time. Basically, we're just going to prove a squared plus b squared equals c squared. And I'll do my best to draw this trapezoid for everyone. I'm better with shapes than with actual drawings. Okay, we know that this is 90 degrees. This is also 90. So B, A, little c, little b, A again, B again. Not to scale. Whoa, whoa. Hold up. C, D, C again. Okay. And it's asking us to use our prior knowledge to prove this. Let's slide over. What we need to know for this is that an area of a trapezoid is equal to A plus B divided by 2 times height. And in this case, our height is actually A plus B, literally. So that means this is going to be equal to A plus B divided by 2 times A plus B. Hold up a second to think about it. Okay, so in triangle terms, if you look at the triangle here, you can basically get the same area by getting the area of each of these triangles. First triangle will be 1/2 A, B. Second triangle will be the C1 right here, which is going to be 1/2 C squared, since both of its sides are C. And then this third one is just going to be 1/2 AB once again. And that's equal to this expression up here. So let's set it like that. And now we actually end up equating the areas. So we'll first just solve what this is. These two add up, so we get AB plus 1/2 C squared, which means that 2AB plus C squared is equal to A plus B squared. What I did there was just multiply 2 on both sides. And now we have 2AB plus C squared is equal to A squared plus 2AB plus B squared. Oh wow, did you look at that? These two cancels out. We have C squared is equal to A squared plus B squared. And that is our QED. Alright, I hope you all enjoyed this simple proofs video. Definitely one of my favorite exercises so far. Proofs do get a super hard to come, which is unfortunate. I think the next exercise is going to be contradictions. This one was, I forgot what type of proof this was. I think it's just direct proof. Yeah, that'll be all.